Imagine it's 8:00 a.m. on a Tuesday.
Always a Tuesday.
Right, always. So your phone vibrates. It's the plant manager at your manufacturing facility in Ohio. The assembly line has just stopped. The robotic arms are, frozen in midair. Every monitor on the factory floor is displaying the exact same black screen with white text.
And it's demanding payment.
Exactly. In cryptocurrency, of course. You hang up, and before you can even process the financial hemorrhage happening by the second, you realize you have to explain this to the board, to your employees, and to your clients.
It's a total nightmare.
It is. But this isn't some hypothetical thriller. For thousands of business leaders navigating this 2026 corporate landscape, this is a statistical inevitability. If you are listening to this right now, you're likely that business leader, a CXO, maybe a board member. So consider this deep dive your operational briefing for the 2026 reality.
Because the modern siege has really evolved. The attackers aren't these loud barbarians at the gate trying to batter down your firewall anymore. They're quiet professionals, and they already have the keys to the kingdom. What makes this era uniquely treacherous is that while you're trying to coordinate this life-or-death operational response, the communication channels you rely on are just drowning in automated synthetic noise.
Yeah, that dual threat is exactly what we're digging into today.
Right.
The mechanics of the modern ransomware cartel and the absolute necessity of using artificial intelligence to build your defense.
Without sounding like a mindless chatbot.
Exactly. Our intelligence stack for this deep dive is incredibly dense. We're pulling from the 2026 Global Cyber Risk Outlook, deep learning architectural frameworks, some advanced Google prompting protocols, and an incredible text generation system based on the industrial design of DRAMs.
Plus a 5-layer visual generation guide and a really granular field manual on identifying undisclosed AI text.
So let's look the monster in the face first, the 2026 Global Cyber Risk Outlook. The numbers here just sort of defy standard risk models.
They really do.
We're looking at an average cost of $5 million per ransomware breach.
And that's just the average.
Right, the average. And the sheer volume of attacks is scaling at this terrifying velocity. The projections show 7,000 victims listed on dark web leak sites by the end of this year. That is a 5-fold increase from where we were in 2020.
Yeah, the velocity increase is really the defining characteristic of this new era. And, the reason we're seeing this explosion, it isn't some sudden leap in the complexity of the malware itself.
It's the business model.
Exactly. It's a revolution in the business model. The Cyber Risk Outlook documents a 30% rise in new ransomware groups. And that is driven almost entirely by the proliferation of ransomware as a service. Or RaaS.
Let's break down the mechanics of RaaS, because I think a lot of people, they still picture a lone hacker in a hoodie typing furiously in a dark room.
Yeah, the movie trope.
Right.
Yeah.
But in reality, it's a franchise model.
Completely. Think of it like a fast food franchise. You have the developers who build the actual encryption software, but they don't do the hacking themselves.
Really? They don't launch the attacks?
No, they lease their software out, they put it on these white label platforms and rent it to affiliates. So the affiliate is the one who buys access to a target, deploys the rented software, and then they split the multi-million-dollar ransom with the developers.
Wow, so it just drastically lowers the barrier to entry for international organized crime.
It does. The franchising allows these syndicates to specialize. Because the affiliates don't have to spend months writing code, they spend all their time researching your company.
Finding the weak spots.
Exactly. They know exactly which sectors have deep pockets and zero tolerance for downtime. That is why financial services and manufacturing are bearing the brunt of these targeted astronomical ransom demands right now.
Okay, so the threat is massive. But our sources actually outline a very specific defense mechanism for leadership. They call it the April Ransomware Resilience Sprint.
Yes, the April Sprint.
The directive here is for boards and CXOs to dedicate a condensed period to operational hardening. And the first mandate is testing backups. But I want to be really clear about this. This doesn't mean just asking your IT director, hey, do we have backups?
Right, checking a box on a form isn't going to cut it.
No. It means forcing a bare metal restoration drill. You literally have to prove, with a stopwatch, how long it actually takes to pull petabytes of data from cold storage and get the servers running again.
Because the difference between theoretical backups and tested restorations is literally the difference between surviving an attack and declaring bankruptcy.
That's a terrifying way to put it, but it's true. And then the second mandate of the sprint is the tabletop exercise.
Right. You pull the executive team into a room, turn off their phones, and simulate a live breach.
The psychology of the tabletop exercise is fascinating to me. because it really exposes the human friction, right?
Oh, absolutely. The technical side is almost secondary.
Yeah, like the IT director wants to pull the plug on the servers immediately to stop the spread,
Yeah.
but then the legal counsel jumps in and says, wait, doing that destroys forensic evidence.
And meanwhile, the PR director is totally panicking because a reporter from the Wall Street Journal is asking why the client portal has been down for 3 hours.
Exactly. So you uncover all these catastrophic misalignments in a conference room on a random Tuesday rather than during a live extortion attempt on a Friday night.
Which is when it always happens, Friday at 9 p.m. Now, the third mandate of this sprint is meticulous credential hygiene and restricting remote admin tools. This is the crucial operational pivot.
Okay, let me test that logic for a second. Because if I'm a CEO, I look at my budget and I see that I just approved like a $2 million expenditure for top-tier endpoint detection and response software, EDR.
Right, the gold standard.
Yeah, I have the best EDR agents running on every single corporate laptop. Shouldn't throwing money at automated security software just handle this? Why do our sources explicitly warn against just adding more EDR?
That is the million-dollar question, literally. Because your multi-million-dollar EDR software is looking for anomalies. It's looking for malicious code executing on a machine.
Okay.
But these RaaS affiliates have adapted. They don't want to trigger your expensive alarms by using some complex zero-day exploit. They prefer to just log in.
Log in. Like an employee.
Exactly like an employee. They buy stolen usernames and passwords from initial access brokers on the dark web, or they find an exposed remote desktop portal that some engineers set up for convenience during a weekend project.
Oh, man.
Yeah. If I use your IT administrator's actual password to log into your network, your EDR software just sees a highly privileged user doing their normal job.
Because the software assumes I am who my password says I am.
Exactly. So the EDR is a safety net for when malware executes, but credential hygiene is the deadbolt on the front door.
Wow. Okay, so your tabletop exercises and strict identity access management, that forms the primary shield. Because the attackers are exploiting structural vulnerabilities in human behavior, not just flaws in software.
You've got
Which means the defense requires massive, coordinated human communication. You have to design the tabletop scenarios, write the postmortem memos, brief the board on the risk outlook, draft new credential policies.
It's a ton of paperwork.
It is. And given the sheer volume of material required for this April sprint, business leaders are relying heavily on artificial intelligence to write it all. You really can't run a modern corporation without these tools.
No, you can't.
But relying on a tool you don't understand is a huge liability.
And to master the output, you really must understand the engine. That brings us to the architectural notes on deep learning from our sources. We need to map the evolutionary leap from traditional machine learning to modern deep learning to understand why the AI behaves the way it does.
Let's trace that evolution. Because traditional machine learning always felt incredibly rigid to me. It required a process called feature engineering, right?
Yes. Feature engineering was essentially the bottleneck of artificial intelligence for years. It required data scientists to manually define the rules for the machine.
Okay, so what does that look like in practice?
Well, if you wanted a traditional ML model to identify fraudulent financial transactions, a human had to sit down and write code specifying exactly what to look for. You'd say, look for transactions over $10,000, look for transfers to these 5 specific countries, look for activity at exactly 3.0 M.
It's like teaching someone to recognize a car by handing them a very specific checklist. Like, okay, it needs 4 wheels, the steering wheel, glass windows.
Right. But the moment you encounter unstructured data, like a photo of a car that's been crushed in an accident, or a fraudulent transaction that uses a brand new evasion technique, the rules fail.
Because it lacks nuance. It only knows what's on the checklist.
Exactly. Deep learning emerged to bypass that human limitation. It doesn't rely on handcrafted rules. It learns context directly from raw data.
So you just feed it everything.
Pretty much. You feed a deep learning model millions of transaction logs, both legitimate and fraudulent, and it independently discovers the underlying nonlinear patterns.
That's wild.
It is. It possesses this insatiable lust for data. Its performance scales continuously the more information it consumes.
But there is a massive trade-off here, isn't there? It isn't just an upgrade. It's a fundamental shift in trust.
Absolutely. With traditional ML, you had high interpretability. Because a human wrote the rules, if the system flagged a transaction, you could literally look at the code and know exactly why it made that decision.
Right. But deep learning sacrifices interpretability for superior performance. It acts as a black box.
Yeah, that black box nature is what makes deploying these tools for corporate strategies so delicate. It delivers this incredibly sophisticated output, but it cannot explain its own internal logic to you.
To trust it, we have to look at the structural mimicry of neural network architecture. Our sources break this down beautifully. A neural network mimics the human brain by organizing into distinct layers.
Right, the layers.
You have the input layer, which receives the raw data, so the text of your board memo or the pixels of an image. Then you have the hidden layers, which are these dense webs of mathematical calculations. And finally, the output layer, which delivers the final prediction.
And inside those layers are the neurons. But, a neuron in an AI isn't a biological cell. It's just a vessel holding a mathematical value. The actual intelligence resides in the connections between the neurons.
And those connections are governed by weights and biases. Let's contextualize weights, because this seems like the core of how the machine assigns value.
It is. A weight determines the importance of a specific feature. Let's say the AI is trying to determine if an email is a phishing attempt. The presence of the word urgent might be assigned a really heavy weight.
Because it's a huge red flag.
Right. The sender's domain name might have a massive weight, but the font color of the text, that might have a weight close to 0.
So the network organically learns which features are statistically relevant to the desired outcome, and it adjusts those weights accordingly.
Exactly. But you also need a mechanism to correct baseline inaccuracies, which is where bias comes in.
Now, in human terms, bias is usually a flaw, like a cognitive blind spot. But mathematically here, it's a necessary anchor.
Yeah, think of bias as a calibration dial. It allows the model to shift the entire activation threshold up or down to better fit the data, independent of the actual input values.
Okay, so the engine runs on this massive series of interconnected calculations. But how does the machine actually realize it has made a mistake and fix itself? Our sources detail the training mechanisms for this: the forward pass and back propagation.
Right. In the forward pass, the data flows from the input layer, cascades through those hidden layers we talked about, and produces an initial output.
And initially, it's just guessing, right?
Oh, completely. It's almost certainly wrong on the first pass.
But it calculates exactly how wrong it is using a loss or error calculation. The sources mention mean squared error as a common method.
Yes. But what happens next is really the genius of the system. It uses back propagation.
How does that work?
The error signal actually flows backward through the entire network. And as it travels back, it meticulously tweaks every single weight and bias by just a fraction of a percent.
It's trying to find the bottom of a hill, basically.
Exactly. Mathematically, it is attempting to reach the local minima. That's the valley where the error calculation is at its absolute lowest possible point.
And data scientists control this optimization using hyperparameters. You have the epoch, which is one full cycle through the training data.
Right.
You have the batch size, because obviously you can't push a terabyte of data through the network all at once, so you process it in chunks. And then you have the learning rate.
The learning rate is critical. It dictates the speed of the weight updates.
I picture the learning rate kind of like managing a high-performance team. If you push the team to change their strategy entirely after one bad quarter, like a really high learning rate, they overcorrect, they panic, and they miss the actual long-term goal. They overshoot that local minima.
That's a great analogy.
But if the learning rate is too slow, it takes them a decade to adapt to the market.
Right, they just get stuck. Now, all this multiplication and addition creates linear relationships. But the world, a cybersecurity threat, human language, the curve of a physical object, it's highly nonlinear.
So to map reality, the network relies on activation functions. The sources refer to these as the gates.
Yes, the gates. The most common one in the hidden layers is ReLU, or rectified linear unit.
Which sounds incredibly complex, but it's actually simple, right?
It is. It just outputs the maximum of 0, or the input value. So if the calculation is negative, it just outputs 0. It forces a harsh boundary.
Just a hard stop.
Exactly. And by stringing millions of these simple nonlinear boundaries together, the network can fold and warp its mathematical understanding to approximate incredibly complex, curvy patterns.
And in the final output layer, it uses different gates depending on the task. A sigmoid function squeezes the final numbers between 0 and 1 to mimic a probability percentage. A ton function restricts values between -1 and 1.
This architecture adapts depending on the data type, too. For instance, the sources highlight convolutional neural networks, or CNNs. These are specifically designed for computer vision.
Right, for analyzing images. They process images by reading the pixels from 0, which is pure darkness, to 255 for absolute brightness.
A CNN uses a process called convolution to literally slide mathematical filters across the image. It breaks the visual data into segments, seeking out edges, textures, curves.
While ignoring the irrelevant background noise.
Right. It extracts the core visual features before passing them into the dense neural network for the final classification.
Now, there's a really vital training technique mentioned in the sources here called dropout. It prevents the network from overfitting.
Overfitting is a huge problem.
Yeah, overfitting is basically when the AI just memorizes the training data, including all the useless noise, instead of learning the actual underlying pattern. So the sources note that dropout randomly shuts off a percentage of neurons during the training phase.
Think of a basketball team where every single play is designed to pass the ball to the star player.
Okay.
If that player gets injured, the entire team collapses because the other players never actually learned the fundamentals.
They just learn to pass.
Exactly. In a neural network, if a few specific neurons become overly dominant, the network becomes really fragile. By randomly dropping neurons during training, you force the entire network to build robust distributed representations of the data.
You force the bench players to run the offense.
Exactly.
I really see the distinction there. Okay, so this is the deep learning engine. We understand the weights, the black box, the optimization. But as a CXO mapping out your April ransomware sprint, you aren't writing Python code in TensorFlow.
No, definitely not.
You are sitting in front of a chat interface. You have to steer this massive statistical engine using language.
And that transition from computer science to communication strategy is where most leaders fail completely. They interact with the AI as if it were a human assistant.
Which is a huge mistake. The sources provide a masterclass in AI steering, beginning with the foundational Google prompting framework.
Yes. The framework requires 4 explicit components: persona, task, context, and format.
So you don't just say, write a memo about our cybersecurity sprint. You have to build a scaffolding.
Right.
The guide provides a pristine example of this. Act as a seasoned ad writer that defines the persona.
Right.
To create a tagline that is the task. About a washing machine's features, the context. In active voice under 6 words, and that is the rigid format.
By doing that, you eliminate the AI's need to guess its parameters. You also have to apply the 3 C's: concise, clear, and consistent vocabulary.
Consistency is a massive vulnerability. Like, let's say you are building a complex incident response plan across a really long chat session.
Okay.
If you refer to the plan as the response matrix in the first prompt, and then casually refer to it as the recovery spreadsheet in the third prompt, the AI stumbles.
Oh, absolutely. Because you force this statistical engine to recalculate the context. It has to suddenly determine mathematically if a spreadsheet shares the exact same semantic weight as a matrix.
You have to use identical terminology relentlessly.
Relentlessly. And never ask for the entire strategy at once. Iterate. Break complex tasks down. Ask for the structural outline before you ask for the prose.
But, even with a structured framework, AI-generated corporate text often just feels hollow. It feels frictionless and totally forgettable.
It does. Which brings us to the most compelling asset in our source stack today, the DRAM's system prompt.
Yes, we are pulling principles from mid-century industrial design to fix modern artificial intelligence.
Yeah.
Dieter Rams was the legendary designer for Braun. His guiding philosophy was weniger, a besser, less, but better.
Now I know what you're thinking.
Yeah, I have to challenge this crossover. I understand why a physical Braun calculator or a record player benefits from minimalist design. You want the physical buttons to be intuitive.
Right?
But how does the philosophy of molding plastic and metal apply to a language model writing a ransomware briefing?
Because Rams wasn't just designing objects, he was designing the user's relationship with utility. A corporate strategy document is a tool. Its only purpose is to transfer critical information from your brain to the board's brain with 0 friction. The DRAM's prompt operationalizes this by forcing the AI to prioritize utility over form.
The first rule of the prompt is utility first. Answer the core problem immediately. Eliminate all the introductory throat clearing.
And the second rule is what makes it truly spectacular: restraint and neutrality. The prompt explicitly instructs the deep learning model. You are a tool, not a companion. Remain completely unobtrusive.
Never use conversational filler, emojis, enthusiastic affirmations, or introductory pleasantries.
Exactly.
That is a revelation. Because I cannot tell you how much psychological energy is wasted reading an AI that enthusiastically declares, "I'd be happy to help you draft that memo."
It's exhausting.
The RAND's philosophy demands absolute clarity and timelessness. No buzzwords, no stylistic fads.
And, crucially, honesty and precision. The prompt dictates that the AI must state its own limitations plainly. And this is my favorite part. It must stop generating text the exact moment the functional requirement is met.
Stop generating text. I love that. In a crisis environment, a dense, mathematically precise 50-word directive is infinitely more valuable than a 500-word essay that dilutes the action items.
Less but better.
Exactly. However, brevity doesn't guarantee accuracy. Even under the rigid constraints of a DITA-RAMS framework, the statistical engine can fail. Before you deliver that operational strategy to your executive team, you have to combat the threat of AI hallucinations.
Evaluation is totally non-negotiable. You must audit the output against 4 criteria: accuracy, bias, relevancy, and consistency.
So is the technical data sound? Does the output unfairly favor a specific perspective present in its training data? Does it directly answer the prompt without drifting?
Let's examine the actual mechanics of a hallucination. Why does an engine capable of passing the bar exam just invent facts?
The sources point out that hallucinations peak when the AI encounters a completely novel problem, when the underlying training data is corrupted, or, and this is key, when it attempts to model real-world physics.
Right, because an LLM is entirely composed of language. It has no physical embodiment.
It doesn't know what gravity feels like.
Exactly. It doesn't know how a specific software integration actually functions in a live, messy server environment. It only knows how those concepts are described in text. Therefore, it will confidently generate a theoretically plausible but physically impossible solution.
You also have to aggressively manage your context windows.
Yes, the context window is essentially the model's short-term memory within a specific chat session, and it is finite.
If I'm using the AI to outline the strict technical parameters of our April ransomware sprint,
Okay.
and then in that exact same chat thread, I ask it to brainstorm casual icebreaker questions for an upcoming all-hands meeting.
You trigger cross-contamination. The neural network's attention mechanism begins blending the weights of the 2 totally disparate topics.
Yeah.
Your icebreakers will sound strangely militant, or your cybersecurity protocols will adopt this casual conversational tone.
Hey guys, let's chat about our bare metal restoration vulnerabilities.
Exactly. You must compartmentalize. Start a new, clean session for every distinct operational task.
Okay, so you've mastered the engine. You have utilized the Google framework, constrained the output with the DITA-RAMS philosophy, and audited for hallucinations in a clean context window.
You've engineered a flawless human-grade strategy.
But as a leader, you are also consuming a massive amount of incoming intelligence every single day. You're receiving risk assessments, vendor pitches, security briefings.
Right.
How do you detect when someone else is feeding you lazy, undisclosed AI-generated content?
For that, we rely on the encyclopedic Wikipedia field guide for detecting AI text that's in our source stack.
Yes.
To spot the fakes, you must understand the core pathology of an LLM, the statistical regression to the mean.
We discussed the math of deep learning earlier, but how does that math physically manifest on the page?
Well, an LLM predicts the most statistically probable next word based on a massive corpus of internet data. Because it relies entirely on probability, it is intrinsically drawn to the average.
Okay, so what does that do to the text?
It systematically strips away highly specific, nuanced, or unusual facts, because those are statistically rare in the training data. And it replaces them with generic, important-sounding abstractions.
The field guide offers a brilliant illustration of this. If you prompt an AI to write about the specific inventor of the first train coupling device,
Which is very specific.
right, the engine will likely erode those granular historical details and replace them with a blurry phrase like a revolutionary titan of industry. It replaces precision with puffery.
It acts like a high school student who didn't read the assigned novel, desperately trying to sound authoritative by using broad thematic vocabulary to hide their lack of specific knowledge.
This regression to the mean is the origin of the now infamous AI vocabulary. We see these words saturating corporate communications everywhere now. The guide highlights specific terms that just exploded in frequency post-2023.
Oh, yeah. If a vendor risk assessment arrives on your desk and it heavily relies on words like Delve, tapestry, vibrant, crucial,
Showcase, testament, pivotal.
underscore, seamless, foster, elevate, landscape, or intricacies.
Yeah, if you see those, you are almost certainly reading unedited machine output. We must delve into the vibrant tapestry of the cybersecurity landscape to foster seamless synergies.
It is linguistic Novocaine. It just numbs the mind completely.
Which is exactly why your DITA-RAMS prompt explicitly bans those specific words.
Exactly. Now, beyond vocabulary, the AI reveals itself through structural tells. The foremost is the avoidance of basic copulatives.
Right, a copulative is just a connecting verb, like is and are.
Yes. The neural network is weighted to sound persuasive and sophisticated. Therefore, it mathematically evaluates simple is or are constructions as too simplistic.
So instead of writing, the firewall is a barrier,
The AI will write, the firewall serves as a barrier, or acts as, stands as, or boasts a.
it's the structural equivalent of a poker tell.
How do you mean?
Well, when a poker player bluffs, they often exhibit an unconscious physical habit that overcompensates for their weak hand. The AI knows it lacks genuine comprehension, so it overcompensates with puffed-up sentence structures.
That's a perfect analogy. We see this overcompensation in its reliance on the rule of three, too.
Oh, it loves the rule of three.
It abhors a single adjective. It will inevitably describe a protocol as robust, secure, and comprehensive.
Never just secure. Always three. And my personal nemesis, negative parallelisms.
Yes. The AI attempts to project deep analytical thought by telling you what a concept isn't immediately before telling you what it is.
It is not merely a software patch. It is a paradigm shift.
This is not just about technology. It is about empowerment.
It artificially manufactures a profound realization.
It is a rhetorical parlor trick, and it frequently culminates in the rigid challenges and future prospects formula.
Because the AI is trained on balanced academic and corporate texts, it feels compelled to hedge its bets at the end of every document.
Always. It will end a memo with a paragraph beginning. Despite its numerous advantages, the system faces several challenges.
Followed by a vague, uniformly optimistic conclusion.
Exactly. But what happens when the sender is meticulous?
Right. What if a vendor uses an AI to draft a proposal, but they manually delete the word delve, they fix all the negative parallelisms, and they smooth out the structure?
The Wikipedia guide details how deep learning leaves deep technical fingerprints, literal digital artifacts embedded in the text.
This is where we move from literary critique to actual digital forensics.
Yes. The most glaring artifact is citation hallucinations. The AI desperately attempts to simulate authority. It understands the visual pattern of an academic citation perfectly.
But it doesn't possess a relational database of actual books.
No, so it generates completely invalid DOIs, digital object identifiers.
You click a link that looks perfectly formatted for a 2026 cybersecurity white paper.
And the DOI resolves to a biology thesis from 1998.
Or it generates book ISBN numbers with mathematically invalid checksums. It will confidently provide a citation for a perfectly plausible-sounding book, complete with a real author and publisher.
But it will omit the page numbers.
Because it knows the entity exists,
Yeah.
but it cannot cite the page, because it has never actually read the text.
The guide warns about placeholder access dates as well. If a vendor's research cites a website and ends with access date 2025 XXXX, they lazily copy-pasted raw LLM output.
We also look for formatting and markup bleed over.
Right. LLMs natively format text using Markdown. They use asterisks for bolding and hashes for headers.
So if an email arrives featuring headers that start with double hashes, or a block of text encapsulated by 3 backticks and the word wiki text,
The machine wrote it, unquestionably.
you also see the structural logic fail. The AI will frequently jump from a level 1 heading directly to a level 3 heading.
Because it prioritizes the visual chunking of information over the actual logical hierarchy of the document.
There are subtle typographical artifacts too.
Yeah.
DeepSeek and ChatGPT default to curly quotation marks and curly apostrophes.
While Claude and Gemini often default to straight quotes.
And the AI notoriously overuses the em dash, the long dash, to force a breathless, dynamic pacing into the text.
But the most undeniable proof is the literal code leftovers.
Oh, these are the best.
These are the catastrophic failures of copy and paste. You are reading a strategic proposal and suddenly, mid-sentence, you encounter a bracketed string like OSSite.0.
Or internal processing tags like turn 0 search 0 or attached file.1.
The model occasionally leaks its own search parameters into the URL strings it provides too.
Right. You might click a link in a report, and if you look at the address bar, the URL literally contains the tracking tag atomsource.chatgpt.com.
It is the digital equivalent of leaving the manufacturer's tag on a tailored suit.
But as we examine all these forensics, the guide stresses a massive critical caveat. We really have to account for the human element.
Yes, you cannot initiate a corporate witch hunt based on a single instance of the word crucial.
Because humans are complex. We code switch between formal and casual registers. We make bizarre formatting errors all on our own.
Perfect grammar or the presence of a subject line at the top of an email does not guarantee synthetic generation. False accusations of AI use erode organizational trust way faster than the AI itself.
Furthermore, the studies cited in the guide reveal a fascinating cognitive blind spot here. Your ability to detect AI text is directly correlated to your usage of the tools.
This is so important. Heavy, expert users of large language models can identify synthetic text with roughly 90% accuracy.
Because they intuitively recognize the statistical regression to the method.
Exactly. They feel the rhythm of it. But individuals who rarely use LLMs perform no better than a coin flip. They are literally just guessing.
If you aren't fluent in the machine's language, you are blind to its accent.
And finally, there's the temporal baseline. Any text generated before November 30th, 2022, the public launch of ChatGPT, is safely, undeniably human.
It is the single hard boundary remaining in our digital archive.
It really is.
So let's pull back and look at where we are. We have mapped the ransomware threat. We understand the deep learning math underneath it all. We know how to prompt for utility using the DITA-RAMS method, and we know how to forensically audit incoming intelligence for synthetic noise.
We have the perfect written architecture for our 2026 security posture.
But text alone doesn't secure corporate alignment. You need visual assets.
You do.
You need a compelling presentation deck for the board or a commanding visual header for the internal communications portal. How do we ensure our visual strategy doesn't succumb to the plastic, hyper-smoothed, six-fingered aesthetic of fake AI art?
We turn to the final asset in our stack, the 5-layer prompt framework for image generation.
The philosophy here perfectly mirrors the DITA-RAMS approach to text, doesn't it?
It does. It is all about migrating from vague conceptual requests to strict technical specifications. You must eliminate the mathematical ambiguity for the engine.
The guide contrasts a typical lazy prompt with an engineered prompt. A lazy prompt is simply a woman holding a skincare product.
And because you provided 0 parameters there, the convolutional neural network defaults to the statistical mean of every stock photo in its dataset.
The result is generic, flatly lit, and immediately identifiable as artificial.
Oh, exactly. To shatter that default, you have to build the 5 layers. Layer 1 is subject plus action.
So you abandon the generic woman.
You define the exact demographic and the precise physical interaction. A 28-year-old Indian woman holding a luxury serum bottle.
Layer 2 is environment and lighting. And the cardinal rule here is never leave light to chance.
Light is pure mathematics to the engine. You must dictate the direction and the quality. Soft golden hour lighting from the left.
By doing that, you are feeding the engine the exact variables it needs to calculate realistic shadows, specular highlights, and surface reflections.
Layer 3 is where the true hacking happens, though. Camera and lens.
Now, if I am a CEO focused on stopping a ransomware syndicate, why do I need to memorize camera lens millimeters to generate a slide deck image?
Because you aren't playing photographer. You are anchoring the deep learning model to the strict physics of real-world optics.
Okay, explain that.
When you explicitly specify shot with a Canon EOS R5 85mm f1.4 lens, you actually force the AI to execute calculations for a shallow depth of field. The model mathematically blurs the background and sharpens the focal point on the subject. This physical constraint overrides the AI's natural tendency to just render everything in hyper-focused artificial clarity.
You literally force the machine to obey the laws of physics.
Yes. Layer 4 is color and texture. You dictate the palette and the tactile reality. Warm amber and cream tones, dewy skin texture.
This introduces the micro-imperfections required to sell the illusion of reality.
And Layer 5 is style and quality tags. You provide the final industry-standard reference points, editorial beauty photography, 8K, ultra-realistic.
The transformation is total. You move from the lazy woman holding a product to a dense mathematical directive. A 28-year-old Indian woman holding a luxury serum bottle, soft golden hour lighting from the left, shot with a Canon EOS R5, 85mm f1.4 lens, shallow depth of field, warm amber and cream tones, dewy skin texture, editorial beauty photography, 8K ultra-realistic.
The output evolves from a synthetic cartoon into a studio-grade asset that communicates intentionality and executive control.
You have mastered the engine across every medium, which really crystallizes the reality of the battlefield you occupy in 2026. You are defending the absolute financial lifeblood of your organization against highly organized, franchised ransomware syndicates.
And simultaneously, you are defending your corporate clarity against the creeping, automated mediocrity of synthetic text and plastic visuals.
True leadership in this era requires a dual mastery. It's not sufficient to merely deploy an EDR software suite or type a basic prompt into a chat window. You must maintain a rigorous, uncompromising standard of human precision in an environment completely saturated with malicious actors and hallucinatory noise.
You have to be the undeniable signal.
You must understand the mathematical architecture of the machine deeply enough to control it, rather than allowing its statistical gravity to average you out into obscurity.
And this actually brings up a final, fascinating implication of everything we've discussed today regarding how AI processes data.
What's that?
Well, if the engine's output is entirely dependent on its input data, and we know malicious actors are using AI to analyze our companies and write targeted phishing campaigns, what happens when we start fighting back at the data layer?
Wait, think about that for a second. If the RaaS cartels are using large language models to scrape our public websites, analyze our leaked documents, and find the vulnerabilities in our corporate structure,
The ultimate defense might not be a firewall.
the ultimate defense might be data poisoning.
Exactly. What if organizations intentionally embed invisible, corrupted text on their public-facing portals? Text that is invisible to a human reader, but ingested by the attacker's AI scraper.
You could theoretically prompt inject the cartel's own AI, forcing it to hallucinate false vulnerabilities or return corrupted intelligence to the attackers.
It completely flips the dynamic.
As you prepare your April ransomware sprints and apply the D to RAMS philosophy to your communications, consider that the future of corporate defense might not just be about locking your doors.
It might be about poisoning the well of synthetic intelligence the attackers rely on.
The siege has changed, and it is time to build a smarter castle.